So welcome back. This is a new chapter, Interfaces, Lambda Expression, and Inner Classes. In this chapter we have three main sections and we will deal with the first section now. The section is divided into three subsections at her turn. This video concerns the first one, which is entitled The Interface Concept, Comparable and Comparator Interfaces. So in this section, we will introduce the interface concept and using the example of the comparable interface, and later we will see how to use also the comparator interface. We always draw your attention to our textbook, which is called Java Volume 1, in the footer of the slides. You can find the slides at the Moodle webpage in the description box, and you can also find in the description box the outline of this video. So what is an interface? An interface is not a class, but a set of requirements for classes that want to conform to the interface. An interface is a way by which a service supplier, it means a method, tells you if your class conforms to a particular interface, then I will perform the service for you. For example, the method sort in the class arrays. It will sort an array of objects under one condition, that the objects belong to a class that implements the comparable interface. What is the comparable interface? It is this line, public interface comparable. It has one method that returns an integer and takes as a parameter another object. As of Java 5, this interface became typed and it takes a type parameter, and the parameter of the compareTo method is of type T, but it always returns an integer. What can we do with interfaces? In interfaces, we may have more than one method. We may have even 0 methods. We can also define constants. We never, however, have instance fields inside an interface. And regarding the method implementation, before Java 8 it was not possible, but since Java 8 it is also possible now to supply static private methods, static methods, private methods, and default methods for the methods declaration, but the methods cannot refer to instance fields. Supplying instance fields and method implementations in general is a job of the classes that implement the interface. For example, for the comparable interface, you have the compareTo method. If we invoke x.compareTo y, we must be able to compare x to y objects and return an indication whether x or y is larger. So we have to return a negative number if x is smaller than y, 0 if they are considered equal in comparison, and a positive number otherwise. Of course, details will follow because this is not only that, but let's take into consideration now that compareTo method, the implementation of this method is the job of the classes that implement the comparable interface. A last point in this slide is the comparison between interface and an abstract class with no instance fields. It is not only that, there are other major differences that we will discuss also in this lecture. So let's consider the sort employees example, and you recall the employees class that we have worked with. Let's take a simpler version of the employees class, 2 instance fields, the name and the salary, and we want now to use the arrays.sort method in order to sort the employees object. So how do we do? First, employee class must implement the comparable interface. So first, you declare that the class intends to implement the given interface. And the second thing is, of course, you supply the definitions for all the methods in this interface. Here is how your class employee will declare that it implements the comparable interface, and you provide definitions for all the methods. There is only one method compareTo, so you provide this definition. And let's suppose that we want to compare employees regarding their salaries. So if the salary is less than other dot salary, return -1. If the implicit parameter salary is greater, return 1. If they have equal salary, the implicit parameter and the explicit parameter, then return 0. There is another easier version to write these three lines, which is to use the double dot compare static method, which takes two values and returns exactly the things we want. So you are advised to use this static method instead of writing these three lines, and every time you have this condition. And also whether the salary is an integer primitive type, you have also the integer static compare method that you are also advised to use because integer subtraction may have some flaws in the extremities of the integer range and whether they are negative, etc., etc. So it's safer to use the compare methods. Here a quick question. So the first quick question, yes, there is a compare for integers and all the numeric numbers, and they are all static methods. You can invoke them directly by calling the class name. Another question, do they override a super compare? Of course not. They are static method, no overriding in static methods. So even they have the same name, but they are different static methods. There is no relation between these methods. This is a polymorphism by name, only by name. Okay, let's continue now and draw your attention again to the public modifiers because this is inside the class. Inside interface, you can skip it. It comes by default, but you have to whenever you are defining a method because if you skip it, it will be default and the compiler will, of course, complain. Another thing is that comparable is typed since Java 5 and you have to implement not only comparable but implement comparable of employee in order to be able to compare to employees. So you compare employees to employees, and in this case you don't have a casting anymore. The other explicit parameter is directly an employee and you can directly compare its salary. So this is our version of comparable employees, and let's check the listing in the listing interfaces. So here is our listing, and as you can see, this is the compareTo exactly how we wrote it, and this is the sort test in which we created an array of 3 employees with 3 different salaries, and we want to sort them, so we don't bother sorting them. We use the service of the method sort inside the class arrays, and then we will print them out, and you can see that when we run, we will have them in increasing order of salaries and not in increasing order of names, for example. So let's check now the Java doc for comparable and for arrays. So this is a comparable interface, and let's see directly the method, the unique method it has, and compare to TO, which compares this object to the specified object for order. We will be back to this documentation in few seconds. Let's check the array.sort method, which has different versions, and we want this one. So array.sort sorts the specified array of objects into ascending order according to the natural order. What is the natural order? It is, you click on it, you get back to comparable. So let's go back to our presentation and continue the details we have to know about comparable. But before that, let's explain why comparable. Because you will say that I can have the compareTo implemented and used without the interface. The Java is strongly typed. This is why. When making a method call, the compiler needs to be able to check that the method actually exists. So somewhere in the sort method, there will be a statement like if A of I compared to A of J in order to know whether it will swap them or not. Regardless of the, for example, algorithm used to in order to sort. You know that there are many algorithms: merge sort, quick sort, bubble sort, etc. But somewhere in the algorithm there must be a comparison of two elements of the array. So the compareTo method must be called, and the compiler needs to know whether these objects have a compareTo method. So this is why they declare that we implement comparable, and yes, we have the compareTo method. After all this explanation, you would expect that to see the Arrays.sort defined to accept a comparable array, since she wants to make sure that the elements are comparable. But sadly enough, this is not the case, and this is of course wrong in the library. The sort method in fact accepts an object array and uses a clumsy cast. The code that is written inside the sort method is of the form if cast to comparable a of I dot compare to a of j, because the a of I and a of j are elements of type object and we are not sure if they are comparable or not. So if a of I does not belong to a class that implements comparable, you will have the exception, class cast exception, and this is of course not advised. You are not advised to do so. Let's go and be curious and check whether what I am telling you is true. We can in fact check this because we can go to the Java source code and inside the arrays class and check it since it's an open source. So let's go, and here is our OpenJDK of 8, and I will try to find the sort method. The sort method. There is lots of sorts, so let me find the void sort. We have 19 void sort, so let's check the void sort, which takes an object parameter, an array of object parameter. Okay, we are here now. So this is public static void sort, and inside the implementation there is a call to legacy merge sort, which is just under it. It's a private method that is a helper method for this sort method. This is very advised to use private method in order to decompose your code. And this private method in its turn, it calls the merge sort. So whenever you want to change the sorting algorithm, you change the call here. So let's call the merge sort void private static merge sort. And inside the merge sort, we just find the clumsy cast of the comparable. So this is true, what we have said is true, and this is not advisable. Okay, so let's get back to our comparable interface that we would like to study in deep. So for this purpose, we will go back to the Java doc and check this interface. I just copied and pasted this sentence here into my slides. So let's read it. This interface imposes a total ordering on the objects of each class that implements it. So each class that implements this interface will have a total ordering, and this ordering is referred to as the class's natural ordering. Whenever you read the name, the word, the expression natural ordering, it means it has implemented the comparable interface. And the class's compareTo method that it defines is referred to as its natural comparison method. So let's go and see the compareTo method contract because it has a contract. So let's go back to the Java doc of this interface comparable and click on method, and there is only one method. We already know that. We click on it, we see the contract. This is the description and we call it the contract because there are rules we must follow. So I also copied and pasted these sentences here into my slides in order to explain them to you. So first, this compares this object with the specified object for order. and how it returns a negative integer, 0, or a positive integer as this object is less than, equal to, or greater than the specified object. The implementer must ensure that the sign of the expression x compared to y is equal to the negation of the sign of y compared to x, not the value, only the signs, for all x's and y's that are compared. And also, this implies that if x.compare to y must throw an exception, if and only if y compared to x throws an exception. So, if one throws an exception, the other must also throw an exception. The implementer in the second point of the contract, it is written that the implementer must also ensure that the relation is transitive. If x compares to y is positive and y compared to z is positive, this implies that if we invoke x compared to z, we will get also a positive value. And finally, in the third point, the implementer must ensure that x compared to y is equal to null, which implies that the sign of x compared to z is equal the sign of y compared to z for all the elements z. So let us first recapitulate the 3 points of the contract, which declares that if you compare x to y, x.compare to y, you must return a negative number if you consider x to be less than y, a null number if you are considering them to compare equally, and a positive number if you consider that x is greater than y. The second point says that if x is greater than y and y is greater than z, then you must have x is greater than z, the transitivity. And the third point says that if x and y compares equally, they must compare the same to a third element. So if x is greater than z, also y must be greater than z. So we will talk about the last remark in a few seconds, but for now, let us see this point in the first point in the contract. This implies that x compared to y must throw an exception if and only if y compared to x throws an exception. For the first impression, you will say yes, of course. But as with the equals method, problems can arise when inheritance comes into play. So let us try to explain how the problems arise when there is inheritance in respect to the contract of compareTo. So let us consider our example, which is the manager class, which extends the employee class. Let's see this light manager class. Here it is. We have an additional instance field bonus because managers get bonus, as you know, and that this bonus must be taken into account, for example, in certain operation. We go to the manager compareTo test class, in which we have our main and we have a manager, car cracker, and an employee. And here we wrote a comparison, and we will see if they respect the contract. So let us run and see that if E compared to M is equal minus 1, it means E is considered less than M, then M compared to E is considered greater than E. And this is true because we are comparing the salaries, and the manager M has a greater salary than the employee E. Where the problem arises is when you go to the manager class and you decide to override the compareTo. Attention here that manager extends employee and that employee implements comparable T, which is comparable employee. Let us see here. Employee implements comparable employee. So by inheritance, manager implements comparable employee and not comparable manager. So I will write here it implements comparable employee and not comparable manager. So at every time you will decide that for you, two managers, one is more important than the other if he has a greater bonus. So I will decide here to override the compareTo to be more specific for managers. So I will override the method and I will choose here to override the compareTo method. And of course, it will propose to override compareTo, and it will take employee other. And here I will compare the bonuses. In order to compare the bonuses, I must cast the other parameter into a manager. So I will take manager, other manager equal cast to manager the explicit parameter other, and then I will compare the bonuses. So return double dot compare this dot bonus with other m dot bonus. And I will go back to my compareTo test, and now I will run. As you can see, in the compareTo, employee compared to manager, he says I'm less than this manager because in employee, as you can see, the dynamic binding, the employee salary is less than the manager salary. But when we decided to compare the manager to the employee, it didn't say I am greater than or equal or less than. It raised an exception. The exception came from manager Java at line 22. It came when we tried to cast to manager the other object while it is not a manager. So this is a class cast exception. This is a broken promise. Why did we try to cast? Because we try to give the employee parameter, which we have the total right to give it, to the compareTo method inside the manager class. So let's go back to the slides. I have written this for you. If manager chooses to override compareTo, it must be prepared to compare managers to employees. It can't simply cast the employee to a manager. So if you write like this is a big no. Okay, why? Because it violates the symmetry rule. Why? Because if X is an employee and Y is a manager, X compared to Y does not throw an exception. However, Y compared to X throws an exception, and this is a violation of the contract. The Java people will not be happy of you. Okay, you will tell me I don't have to compare the bonuses, I can compare the get salaries. Yes, you can, but this is an example. This is only an example. In some cases, you have to, you want to compare special things for manager. So how do we do? What is the solution? There is a solution, and the inheritance problem remedy is like the equals remedy because it is the same situation with the equals. You saw this in the previous chapter, and we will propose to do the same remedy. You have to choose either of these two scenarios, two distinct scenarios. Either the subclasses have different notion of comparison, or there is a common algorithm for comparing subclass objects. So if they have different notion of comparison, you should outlaw the comparison of objects of different classes. So each compareTo method should start out with the test. If getClass is different than other getClass, then throw the exception. You throw the exception at the level of the superclass, and this way you ensure that the exception is thrown both ways. And in the other case, in the common algorithm for comparing subclass objects, you prohibit to override the compareTo method in the subclasses. You simply provide a single method in the superclass and declare it as final. So you choose either one of these options. Okay? A third case example, maybe you will tell me neither of these options is fine with me. I want another option, just like we did with equals also. You consider that managers are better than the regular employees, regardless of their salaries, okay? But with between the employees themselves, you compare the salaries. Between the managers themselves, you compare the salary. But even if a manager has a less salary than an employee, it will be considered better. Okay, if we go to a dining gala, you will sit the managers together on one table. They are considered better than the employees who will be sit on another table. Okay, if you are sorting an array, you want all the managers to come first, regardless of their salary. So you need to establish, in this case, a pecking order. You supply a rank method inside the employee class, and you have in each subclass, you override this rank method to implement a single compareTo method that takes the rank value into account. So we will see now in scenarios, the three scenarios, the two distinct scenarios, and the third case example in coding. So let us see the first scenario. Subclasses have different notions of comparison. If subclasses have different notion of comparison, you have to compare the get classes yourself. So you go to the employee class and you say the compareTo should not begin like this. I will begin by comparing the classes. If different than other dot get class, so I will throw an unchecked exception. That's why I don't declare it, but I want to draw your attention to the get class comparison using the different operator, because we saw in the previous chapter that the get class will return a unique instance of the class. So you can compare them with the equal and the different. If you didn't see this lesson, go back and see this lesson. So if this dot get class different than other dot get class, throw an uncheck exception, which is a new object of class cast exception, and the other will remain the same. And here, if we go to the manager compare test and we run again our example, we will get class cast exception from the first and from the second, of course. So if you want, I will comment this to show you that the class cast exception is raised also by the second, and they both raise the unchecked exception, class cast exception. If you choose to have a common algorithm for comparing subclass objects and you don't want the subclasses to override your method, you can go and delete this method compareTo. You don't allow overriding of your method. How do you express that you don't allow overriding of your method? You say that public end compareTo, public final end compareTo, don't override me. And you remove this line. I can allow to compare managers to employees, so you remove the raise exception, and here you save. You go to your manager compareTo test, you run, and it preserves the symmetry rule. If you choose to do the third example, you want them to be compared, but you don't want only to compare according to their salary. Back to your employee class and you leave the compareTo final, but you compare the ranks. So you will invoke the rank, for example, int rank compare, okay, and then equals integer dot compare the ranks, which are protected methods. This dot rank method with other dot rank. So here I am defining a rank method, which is I still have to define, and then we will have the comparison, the salary comparison, and salary compare equals double compare, for example, this dot get salary with other dot get salary, which are also methods. And then if they have the same rank, compare the salaries. If they don't have the same rank, if rank compare equal 0, rank or compare equal 0, return salary compare, else return rank compare. Now let's define rank. Protected int rank. If you are inside class employee, your rank is, for example, 0, because an ordinary employee is less than a manager, is less than a secretary, etc. And you can override this rank from within manager. Okay, source override, and then here, if you are a manager, you will return a higher rank, 1 or 2 or etc. So here we will return 1 because in this example we only have the managers and the employees. And we go to the manager test and we create another M2, another name, and for example the same salary and another bonus, and we have the employee, and now we will add the comparison between the employees themselves. So M2 compare to M and M compare to M2. Let us run. So E has the less salary, even if the employee E has the greatest salary of them all, even if he has a salary of $90,000 per year, he will still be less than the managers, because we will compare first the rank. So the employee is less than the managers, and between themselves, the one who will get the higher salary has the comparison. Okay, so this is the example of the third case. So this is the third case implemented here. You supply a rank method in employee class plus have each subclass override this rank method, and you implement a single compareTo method that takes the rank value into account. Let's get back now to the compareTo contract and let's check this last remark. It is strongly recommended but not strictly required that x compared to y equal true when x equals y. So notice here the equal operators. And this is logical. If you compare x to y and you consider them as equal, when you invoke the equals method of the object class, it must return true. So, but this is strongly recommended but not strictly required. Generally speaking, any class that implements comparable interface and violates this condition should clearly indicate this fact. The recommended language is: note this class has a natural ordering, which is compareTo, that is inconsistent with equals. So let us focus more on this remark, and let us say that most classes in the Java API that implement comparable follow this advice. A notable exception is the big decimal class. Consider x to be equal to new big decimal 1.0. This is a constructor that takes a string as a parameter, and another y that references to new big decimal object initialized using the constructor and given 1.00. Then n x equals y is false because the number differs in precision. But x compared to y is 0 because they are considered equals in the line of numbers. Ideally, it shouldn't be, but there was no obvious way of deciding which one should come first. So this is an example of a class that doesn't respect the recommendation and has declared so in her documentation. So let's go and see the documentation of big decimal class. So big decimal class. And where does this state that her natural ordering is greater than is not respecting the equals? Control F. Okay. API note. So let us end this subsection by mentioning the comparator interface, which is important as the comparable. You have seen until now how you can sort an array of objects provided that they have a natural order, and by natural order we mean that they are instances of a certain class that implements comparable. We do all agree. You can, for example, sort an array of strings, not only an array of employees, because the class string implements comparable string and it provides them with a natural order according to the dictionary order. Now, suppose we want to sort strings by increasing lengths, not in dictionary order, and we don't want to change the compareTo method because we cannot, or because we don't want. So there is a second version of the Arrays.sort method which take two parameters, the array and a comparator. What is a comparator? A comparator is an instance of a class that implements the comparator interface. And this is how the comparator interface looks like. Public interface comparator typed with a type parameter t, and it defines among other the compare method, which take two parameters of this type t and returns an integer. So as you have already guessed, compare works approximately the same thing as compareTo, but with two implicit parameters instead of one implicit and one explicit parameter. So let's check the Java doc for comparator and arrays. This is a Java doc for comparator, and if you click on method, you will see many methods, but all these methods were not here before Java 1.8. We had only the equals and the compare method. All the other methods are a very nice additions since Java 1.8, so since Java 8. So what about the compare method? We will read compares its two arguments for order, returns a negative integer, 0 or positive integer, as the first argument is less than, equal to, or greater than the second. And you can continue read in order to see what is the compare contract and how to follow the compare contract and how to follow the recommendation of the compare contract. And when we will take the generics chapter, you will understand why is comparator typed and what is the use of the type parameter inside compare. But for now, we will see the arrays sort in order to see where is the sort of the arrays that takes a comparator. So this is the sort of the arrays which takes a comparator, and it can sort the specified array of object according to the order, not to the natural order, but to the order induced by the specified comparator. And this is by opposition to the first sort we studied together in this subsection according to the natural order. So the sort which takes a comparator, it sorts them by the order induced by the specified comparator C. So let's continue in our example and let's define a class which implements the comparator of string this time. And inside this class, we will define the compare method and which will compare only the length of these two given string first and second. And to do compare now, we just have to create an instance of this class. We have to create var comp equal new length comparator constructor, and then we will use this length comparator and over which we can invoke compare. And in order to use the sort in the arrays class, we can create, of course, in order to try, we can create an array of strings and then invoke the sort given this array, and as a second parameter we can give this new comparator. We can create a new comparator of this class and give it. So the output of the sorting of this array will not be equal to Mary, then Paul, then Peter, but to Paul, Mary, Peter, or Mary, Paul, Peter. It doesn't matter, but what matters is the number of letters. The smaller strings come first. We will see later a compact how to write in a concise manner and how to use comparators much more easily with lambda expression. But for now, let us see on our environment let us try this example. And you can see here I created an array of 4 strings, and the natural order of this array when sorted using the sort method given alone is the dictionary order. But the order using the comparator, our class comparator, which we just wrote here, will sort them using the ascending lengths of the strings. Okay, Anna, Mary, Peter, and Anthony. Whether Anna, Mary, or Mary, Anna, it depends on the implementation of the sorting algorithm, but we don't care. We care about only the lengths of the. I'm very tempted to try a comparator over my class employee, so I will go and instead of doing this for the strings, I will do this for the employees. So I will do the comparator for the employee, and I will name it, for example, name length comparator, which I will be using later. And then I will compare the name. So I will take an employee first, employee second, and then I will compare the names. So first dot get name dot length, and second then get name get length. And then I will create here an array of 3 employees, and I will try to sort them. Here is my array. I put 3 employees inside it. I sort it without a comparator, so the natural order will come out from the poorer to the richer, and according to the comparator, it will come out in ascending order of the name length. So Karl Krag before Tony Tim Tester and before Harry Richard Hacker. So this was about our comparator interface. We will see more of this interface later in the next lessons. And for now, we finished the first subsection, the subsection 1.a. Next, we will see the subsection 1.b, which is properties and features of interfaces in general. And then we will see the subsection 1.c, which is especially for the clonable interface and for the object cloning. This is also a very important subsection. Also, the subsection B is very important because it shows the new features of the interfaces in the new versions of Java. So see you next time.